And semi-solid, it means using some of the reducing some of the liquid electrolyte and using some solid. By doing this, we achieve higher density, but also achieve higher safety. And more importantly, our semi-solid state batteries adopts like a safer solid electrolyte membrane, and the membrane can fix all the liquid in place. So actually, there's no free liquid flying around inside the battery, and it's all stuck in place. So the liquid doesn't move around, which is the core reason why it's so much safer.
Well, today I'm excited to be joined by the CEO of Zendure, and we'll talk a little bit about Zendure here in a minute, but the CEO of Zendure, Bryan Liu. And we're going to talk about several things, but one of the big things we're going to talk about is the SuperBase V, which is a new portable power station. It's portable in one sense, but it's also a modular system, as we'll hear about, where you can connect it to your home and use it as a battery backup system for your home. But really the headliner for this SuperBase V is the fact that in addition to the lithium iron phosphate battery option, which we'll talk about, they also offer a semi-solid state battery option. And so that's interesting technology. It's cutting edge technology. It's really breaking technology. So that's really why I had Bryan on today. And this is really what is interesting me about this product. Not only the product seems great, but the technology of the battery. So Bryan, I appreciate you coming on today to talk about this. Thank you so much for that. As we get into this conversation, can you tell us a little bit about yourself and a little bit about Zendure, what kind of products you offer?
Thanks for having me, first of all, John. And I watched a lot of videos on your channel, and they're great. And yeah, Zendure is actually one of the fastest growing energy tech startups. We're based in the US, in Silicon Valley in the US, and also in the Greater Bay Area in China, and also in Japan. So we are a global company. We're still small, but we are global. We have 150 employees worldwide, and about half of those employees are engineers. So we really emphasize on R&D and technology. Yeah, and we make home energy solutions like power stations, and also smart home panels and solar panels, etc.
I really like that you're a company of engineers. I think that's really key. I think sometimes companies can skew towards the sales side, maybe, but I like that you're a company of engineers. It means you're going to have great products, which I haven't tested them yet, but from what I see, they look like great products. Even the previous products that you are currently selling. The SuperBase V is currently a part of a Kickstarter campaign. But it seemed like when I looked up the Kickstarter campaign, it was unique in the sense that you're already making this product. It's not like some Kickstarter campaigns where it's like, yeah, we might deliver this in a year. It seems like you're actually going to start delivering some first product this year. I mean, this month even, right? Yeah.
End of this month, correct.
Yeah. So it's a pretty incredible thing. We'll put a link to that Kickstarter. But thanks. So let's move into the product a little bit here. Let's talk about the SuperBase V for a minute. So we'll talk about semi-solid state battery. We'll talk about battery technology in a minute. But besides that, so just set that aside for a minute, just as we get into this, so we know what we're talking about here. Can you talk about the SuperBase V? What's unique about it, and why is it different from all the other power solutions? There's a lot of home energy power solutions. There's a whole lot of power stations, portable power stations. Why is this product different, and why should people care about this one?
Yeah. Well, traditional home energy storage systems, like the ones you usually see that comes with the solar roof systems, are usually like regarded as an accessory of an on-grid solar power system. And so you can't buy them actually from any retail channels, right? And you have to leave your email or have an installer call you, and then they tailor make one system for you, and then you have to apply for permission from the homeowners association, the electricity company, and the local authorities. And this whole process can take several months or even over a year. A lot of people are complaining about that, actually. So this is one of the biggest difference between that, because the SuperBase V is a plug-and-play system. You can just buy online, and we can ship to your door, and then you can just plug and use it right away. So it's very portable and very easy to install. especially for people who already have a gas generator, they have a transfer switch already, and you can just plug into the transfer switch. But if you don't, then you just need to install a home panel, which is also very easy to install. Comparing to other power stations on the market, portable solutions on the market, actually is one of the biggest and most robust solution out there with dual voltage and also seamless UPS. And it's also the smallest. We have, the one main unit comes with 6.4 kWh, and a satellite battery also comes the same capacity. So it's already a big volume to start with, and also you can expand up to 64 kWh of capacity. So it's one of the largest portable systems out there. Yeah.
Yeah, that's incredibly large. Being able to have 64 kWh of backup on your house. I mean, that's amazing. Let's move into the batteries for a minute. So obviously you mentioned that there is there's a 6.4 kWh version. We've talked about that. There's also a 4.6 kWh version. Yep. So the 4.6 kWh version uses a lithium iron phosphate battery technology. Yep. The bigger version, the 6.4 kWh version, uses semi-solid state batteries. So first of all, I'd like you to talk about why is there two different versions, and why did you choose those two different kinds of batteries? Why lithium iron phosphate? Why semi-solid state? Why those two technologies? Why two different sizes?
Sure. Yeah, because a lot of people actually are when we are considering a system, they usually have a battle between LFP or NMC. Because the NMC usually have a higher energy density. So that means they can have the more capacity with the same size or same weight. But then again, there are a lot of safety concerns about NMC, right? And so people choose LFP over NMC more and more. But LFP has a lower capacity, so it adapts to different scenarios. For people who care more about energy density, and they need some higher capacity on site for mobility, for example, for people who usually work on site on the outdoors, they would prefer something higher capacity. So we designed this semi-solid version, which has actually higher density, but it's actually much safer than traditional NMC. For people who mostly use it as a stationary product at the home, and they want to charge it every day and on a daily basis, so they can choose a lower capacity version. Also, it's more cost effective. So I think offering two versions makes just offer more opportunities and more choices for people to choose. Yeah.
Let's go ahead and move into, I was going to talk about this later, but I think this is a good time to bring this up. Let's go ahead and talk about the life expectancy, the life cycles between these two versions. What kind of life cycles do you expect? How many charges do you expect out of the LFP versus the solid state, semi-solid state version? And then what makes, let's talk about safety as well. So talk about life cycle, first of all, and then go into safety between these two chemistries. What are we looking at? How safe are these batteries? You mentioned some issues with NMC, but let's talk about these two types of batteries.
Sure. Well, the cycle life of those two are quite different. The LFP obviously has a higher cycle life, and it has a 3,000 cycle life and to 80% capacity. The semi-solid version, on the contrary, has 1,500 cycle life, but it's already 3 times higher than the normal NMC batteries we see on the market, because it's a EV grade semi-solid NMC battery. So I will talk about the chemistry later on. Yeah, but that's the cycle life. In terms of safety, I think the both versions actually has very high safety standards. As you know, LFP is already very safe comparing to traditional NMC. While the semi-solid battery have even higher safety standards than LFP, not to mention NMC. Yeah. So these two batteries both are safe. It's just that the semi-solid battery are even safer.
Can you talk about some of the tests you ran these batteries through, penetration tests and stuff, and talk about some results there? And we can put up a video of some of that. But can you describe some of those tests real quick for our audience?
Sure. Yeah, especially the semi-solid version, we have we have conducted a lot of safety tests, and the most rigid one is the so-called penetration. You use a needle, to penetrate it. We have international standard for that. It's a IEC standard, and actually we can pass that. Yeah, so it's extremely safe. Yeah.
Yeah, that's definitely an important thing, especially for something like this that's sitting in your home, maybe in the garage or somewhere like that. So I think that's super important. I'm glad there's a strong focus on safety for your products here. Now, let's talk about semi-solid state batteries. When we talk about normal batteries, we have liquid electrolytes. That's a standard lithium-ion battery that's on the market today, like you find in most electric vehicles, pretty much all. Then you move to the opposite extreme, which is a solid state battery. It has solid electrolytes and some different kind of cathode anode chemistries often. What is a semi-solid state battery? What's the in between there? Can you describe this to me and how this is different from a solid state battery and how it's different from a traditional lithium ion battery?
Yeah, sure. Actually, batteries are commonly classified according to the cathode materials like LFP or NMC, right? And but solid state batteries are different. It's a kind of it's a class of its own. It's just defined by the state of the electrolytes, and so solid state batteries are an iteration of conventional liquid electrolyte batteries. And semi-solid, it means using some of the reducing some of the liquid electrolyte and using some solid, but it's a mixture of both. And by doing this, we achieve higher density, but also achieve higher safety. Yeah, so it's a balance between energy density and the safety. But the cathode of the solid state battery that we chose is still NMC, so it still has a very high energy density. Yeah.
Okay, so by reducing the amount of liquid electrolyte, that can improve the safety of the battery, basically, is what we're talking about here.
Yeah. It's, so normally traditional NMC has about 15% of the weight is from the liquid electrolyte, and solid state or semi-solid state batteries has only about 8%, about half of that. So it reduces like 50% of the liquid. And more importantly, our semi-solid state batteries adopts like a safer solid electrolyte membrane, which is very different from other batteries. And the membrane has an interface modifier between the anode and the cathode. And the membrane can fix all the liquid in place. So actually there's no free liquid flying around inside the battery. And it's all stuck in place. So the liquid doesn't move around, which is the core reason why it's so much safer.
Very cool. And I know previously you're not able to talk about where these batteries come from, who makes them, et cetera, but interesting. And I appreciate you sharing what you can about that. Let's talk about cost here. So I imagine that these semi-solid state batteries are more expensive. I certainly know they're more expensive than lithium iron phosphate. That's one of the lower cost batteries, even impressive as it is, it's a lower cost battery. Is it more expensive to buy these semi-solid state batteries versus a traditional NMC?
Yes, definitely. Because now it's still in the early stages of commercialization. Actually, we are the first one to use it in the home energy storage system. Although there are some high-end EV car manufacturers have been using it. I can't disclose the name, but they're world-class car manufacturers in China, in Germany, and then also in the US. So it's in confidential information right now, but we can disclose later. So it is definitely more high-end and costs more. It's like 40% more expensive than traditional batteries. But we're offering this technology to the Kickstarter backers because we want to democratize this technology to benefit more people. So the cost actually we are offering is only slightly more expensive than the LFP batteries. So because we lowered our profit margin on this model.
we've talked, I believe we've talked enough about the chemistry of the semi-solid state batteries. I'd like to, let's talk about energy density for a minute. So obviously one of the things that people talk about a lot about batteries, something I talk about a lot on my channel, is energy density, because that allows you mentioned this beginning, you mentioned earlier about, offering the two different versions. And if you need a little bit more energy density, you offer the semi-solid state version. But nonetheless, as you mentioned on your Kickstarter page, the energy density of these semi-solid state batteries is around 228 watt hours per kilogram. So that's still a little bit less than traditional lithium ion batteries. For instance, like your 2170 batteries, cylindrical 2170 batteries found in a Tesla Model Y or 3. Those are somewhere around 260 watt hours per kilogram. But I guess the reason you go with this technology, even though it has a little bit lower energy density, is just about safety, correct?
Yeah, actually, I can talk about a little bit about that because the primary goal of contemporary cell design is to achieve balance, right, between the performances, the different parameters, a lot of the parameters like energy density, charge discharge rate, cycle life, safety. You have to consider a lot of combinations for different scenarios. With the continuous change of battery application scenarios, the performance requirements of the batteries also diversify, and so we purposely choose this kind of a chemistry mixture. It's a low nickel material. It's a 532 composition of NMC, comparing to the traditional 811 with the high nickel composition, so that we have a higher safety performance. And also, we used thicker copper and thicker aluminum films, so that we have an actually even higher safety performance. So yeah, choosing this is by purpose. Yeah, so we can achieve actually 300 watt hour per kilogram if we want to, if we use 811 or or thinner copper or aluminum films. We can easily do that, but we chose to because we think it's not necessary. Yeah, so it actually depends on the scenario. Because for this application, we think it's good enough. And also the cost is if we choose that density, it will cost even more. So right now it's already 40% more expensive. We have to have a balance between cost, cycle life. Cycle life is another factor as well, actually, because we have 1,500 cycle life, which is 3 times higher than traditional 811 materials. So I think it's a choice. Yeah, not a limit.
I think that's a great answer. It's interesting that you said, if you wanted to create a battery that's maybe a little bit less safe, you could have made the thinner foils. You could have done some tweaks to it, gone to an 811 NMC 811. But I like what you said there, and I think sometimes I'm guilty of this. I'm sure sometimes people like myself like to focus so much.
Push for the limit, right?
Push for the limit, push for that 300 watt hour per kilogram. But maybe we don't need 300 watt hours per kilogram. I think in this particular case, 6.4 kilowatt hour device that can be, you can add the satellite batteries, which we'll talk about in a minute, and get that up to 64 kilowatt hours. I mean, that's incredibly large. And I don't know, what is the semi-solid state one weigh? What are we talking about? A little bit over 100 pounds here for that device?
It's actually 120 pounds.
120 pounds. Okay. And it has wheels and stuff, so you can wheel it around,
wheels, correct?
Yeah,
exactly.
Yeah. So I mean, that's heavy.
It even has a powered wheel. So it's powered assistant. So you need to just push a little bit and it will start rolling automatically.
Yeah. So heavy, but tons of storage. I think it's I'd rather have a safer device that maybe had a little bit more weight. I mean, just maybe 20 more pounds or 30 more pounds. To have a safer product. So I like what you've done there. And you're a company of engineers, as you mentioned earlier, and you've made the choices. You haven't just taken a product and just find the most energy dense battery and pop it in there. You're looking at safety. You're looking at life cycle. You're looking at all these things, and you've come across this particular balance. So I like that. Let's go back to the SuperBase V itself. Let's talk about that product. And let's talk more about the modularity. So you mentioned earlier plug and play. You mentioned, it's pretty easy. You can ship the product to the customer. They can connect it and get going. Even easier if they have a transfer switch already installed. But even if they don't, you sell the home panel. Talk a little bit more about the modularity. Talk about satellite batteries, the SuperBase V unit itself, the home panel. Talk a little bit more about those different pieces, how they go together, how they work together.
Okay, great. Yeah, actually, yes, one of the coolest things about SuperBase V is the modularity, and each main unit has 6.4, and then each battery also has the same capacity, and you can connect up to 2 main units together, and each main unit can connect to another 4 satellite batteries. That makes the total of 64 kWh capacity. It's huge, and also. With the home panel, with EV outlets, the name is home panel with EV outlets. It has 2 EV outlets on there, so you can actually plug in 2 EV chargers on there, so that you don't have to install EV chargers if you happen to have electric cars. And also we have other components like portable solar panels that you can just install in your front yard. You don't have to install on the rooftop, because that will take a lot of manpower and very expensive to install. So some people prefer to just a easy layout in their front yard or courtyard. And also we have satellite plug, which then you can automate with the home panel and the SuperBase V units and the batteries together. You can create automation rules. For example, when the battery is below a certain percentage, you can use the plug to automatically shut off some of your appliances to save energy. Yeah, so it's a complete modular system. It's very flexible. You can there are a lot of different components you can choose from. Yeah.
Very cool. It's a really great looking system. Let's move to like the I think what I read on the Kickstarter campaign and kind of checking out the product, it appears like this is a pretty fast charging device, whether you're charging it from your solar panels. If you have enough solar panel connected to it, you can charge this thing pretty quickly. I assume you can also charge it from the grid as well pretty easily. So let's talk about some of the actual technical specs when it comes to how fast, how many, what kind of power are we able to supply to this? How quickly are we able to charge, say, like a 6.4 kilowatt hour SuperBase V? Talk about that a little bit with solar panel connected or the grid charging.
Sure. Yeah, we have a very strong MPPT controller inside, so that you can actually recharge using solar through the XT90 port, up to 3,000 watt. So that means with the 6.4 model, you can also charge it within about 2.5 hours. So also we support dual charge, which means you can charge with solar and then use AC to charge it simultaneously. And then you can charge up to 6,600 watts, but you need to connect a battery to it to achieve that. Yeah. So in terms of AC charging, you can charge it using a 120 volt AC outlet up to 1,800 watts. But if you have a 240 watts, which is the cool thing about SuperBase V, you can charge up to 3,600 watts from AC or from any other EV charging stations, level 2 EV charging stations out there. So you can actually charge in the house or charge it on the go. So these are very flexible charging options. Yeah. And in terms of output, you can, it's very similar to input actually. You can output 1,800 watts via the regular 120 volt outlet. You can also output 3,600 watts using the TT30 outlet at 120 volts and 30 amps. But there is also another option where we output 240 volts at 16 amps, which is also up to 3,800 watts. This is a very unique feature. Yeah, none of the other power stations out there do this.
Very robust system. In addition, great charging power capabilities, great output power capabilities. and tons of different ports and outlets. Like you have 120 volt outlets, you have 240 volt, you have, a bunch of other different kind of ports.
Yeah.
Maybe there's some you haven't even mentioned. Like what kind of devices can you connect this to besides just your traditional AC devices? Like, can you talk more about the ports that are connected?
Sure. The TT30 is usually meant for RV because it provides a very high current at 120 volts. For the 240 volts outlet, it's called a 620 outlet, which you can easily see. Usually see when you if you have a Tesla car, you'll notice that actually the Tesla charger, the wall connector that comes with Tesla has a 620 plug, so that it means you can plug your charger right into it. A lot of high power devices like like some of the water pumps, some oven, and some of the industrial applications has a lot of 240 volt requirements. So yeah, the application is endless. Yeah.
I also noticed that you have it looks like a pretty good phone app. Could you talk about the phone apps? I assume there's both Apple and Android capabilities here. And what can you do with the phone app? And how can you control the SuperBase V? What can you do with that phone app?
Yeah, we actually we are very big in terms of smart integration and smart automation, which is one of the key features actually. We have a separate interface for each device, for the main unit, for the satellite battery, and for the home panel, and also for the satellite plugs. Each device has its own unique interface. But on top of that, we have a automation section where we can set rules that interact with the other devices, that create rules based on the capacity, rules based on time, rules based on even your TO time of use rates in the home. So you can actually set an unlimited number of automations with it. Rules like, for instance, if the main unit is below 50%, you can turn off one of the critical loads. There are 10 critical loads in the smart panel, and you can turn off the complete one of the complete critical loads, or you can turn off a particular device that's connected to the satellite plug, to give you more accurate control of the energy consumption. You can also make use of the TOU rates by charging at midnight and discharging at the busy times, so that you can save money. Yeah. So, but last but not least, my favorite part is actually the SuperBase V is also connected to smart home systems like Amazon Alexa and Google Home. We're also working on Apple HomeKit, because a lot of people are also asking for that feature. But right now we are only compatible with Amazon Alexa and Google Home at the moment. So you can actually control the devices using voice command, which is very, very cool. You can ask for the capacity of the main unit, or you can set up some automation rules. It's up to you. Yeah. So the many fun ways to use it.
Well, just Bryan, once again, thank you for coming on and talking about the battery technology. You've been very generous with the information you've shared. If you just want to close us with anything that maybe I didn't ask about that you'd like to talk about, and also if you have a specific way that you'd like my audience to either connect with you or your company, if you just want to mention anywhere that you'd like them to find you.
Well, our Kickstarter campaign is actually live right now, and also it ends on November the 18th. So you still have a chance to grasp some of the early bird offers we have. And also you're welcome to join our Facebook group by searching SuperBase V in Facebook. And you can join the club, and also we're all there to interact with everybody, and we all answer any kinds of questions that you can have in the group. So welcome to join there.
Very cool. Well, thank you, Bryan, and it's been a great conversation.
Thank you, John.
Please let me know what you think about all this in the comments section below. And also, if you work in the battery industry or the automotive industry and you'd like to share insights with me, feel free to email me. My email address is John, Jon, @cleanerwatt.com. Again, John, Jon, @cleanerwatt.com. patreon.com. And also, I'd like to take a moment to thank the Patreon supporters who support me every month and help make this content possible. A special thank you to my performance supporters and also the other supporters listed on the screen. If you'd like to find out more about the Patreon community I've set up, I'll put a link in the video description. Thank you so much.